Good afternoon, everyone. Welcome back. So, when we were preparing for this presentation, we were thinking, what are we going to talk about? How are we going to put together 30 minutes talk and make the most out of today's session? So, and then we look at our conversation with customer, and quite often we have conversation around DevOps, automation, and security being an overarching themes. So we put together these talks today, and we're going to start right off with security checkpoints in the software development lifecycle. And then I'm going to show you two demos on how you can kick off a Secure-SDLC. And my co-speaker, Ahmed, is going to talk about software supply chain using a artifact signing, and followed by a demo. And then we'll wrap up the session. In today's fast-paced world, enterprises face a number of key challenges. Constant and disruptive technology, like quantum computing, generative AI. Consumer demand seamless experience, personalized offering, which enforce the enterprise to reimagine their strategy. Simultaneously, companies have to navigate complex risk from a cybersecurity to regulatory compliance. So in this ever-changing environment, we have to adapt to agility and speed to market. And you might wonder, what does it have to do with Secure-SDLC, which is about integrating security at every single point of your software delivery? If you prioritize security from the beginning, there are numerous benefits. You can enhance customer trust, you can reduce vulnerability risk, and you can remain competitive in this ever-changing environment because you have got a good foundation. And this is what we're going to talk about today. Imagine you're building an application in the banking industry. And during the design phase, you realize the need for a strong authentication mechanism. So during the design phase, you incorporate threat modeling to prioritize and identify risk. You perform the security design review to incorporate two-factor authentication, strong communication protocols. During development, your developers follow secure code guideline, start writing code with security in mind, and this is going to be our first demo. In CI/CD integration, we all know and experience that CI/CD can really enhance our software delivery. But a good question to ask here is, how can we improve the stability and the quality of our software? And that's going to be our second demo, and I'm going to show you how you can integrate security in your CI/CD pipeline. During deployment, artifact signing and signature verification is super critical to ensure that your software comes from the trusted and authorized source. Perform penetration testing to uncover any weakness in your application. Then post-deployment, we're not done yet. So during post-deployment, continuously scanning your application from emerging threats, continuously patching your application to ensure that your software is secure and compliant. So hopefully this gives you a full picture of what a secure SDLC looks like, and you can integrate it into your software delivery. So I want to put this into a practice. What you're seeing now is a very high-level architecture of what we're going to build today. And I want to walk through a few steps. So step one, we're going to set up a project. Step two, we will create a continuous integration and continuous delivery pipeline, so CI/CD pipeline. But in order to do that, I want to introduce Amazon Code Catalyst. Amazon Code Catalyst is a unified software development service, and it's really an help customer or builders to build and deploy software on AWS. And a few features that I use in my demo that you're going to see in a minute. It has a built-in project setup that really enhances you to set up the project end-to-end really easily. Built-in security features that you can incorporate to create a dashboard, like security dashboard and security reports. Also, fully customizable CI/CD pipeline that you can design how you want to introduce your testing strategy. So that's what you're going to see in the first demo. Step 3, we have development. And step 4 is our build stage. So I'm going to talk about step 3 and 4 very shortly. So let's take a look at in the Code Catalyst console. And we're going to do the step 1 and step 2 in this demo. In the Code Catalyst console, let's create a new project. Next, we're going to create a repository. Here, you can link to the existing repository like GitHub. You can bring an existing project into Code Catalyst if you wish to, but here we're starting from scratch. So let's create a new repository. Next, we will create environment. In Code Catalyst, environment is a running instance that our code is going to deploy to. We're still in the development stage, so let's keep everything in default and create environment. Now we have got an environment ready. I want to spend a bit of time on our CI/CD pipeline that we can use in the Code Catalyst. In the Code Catalyst world, CI/CD pipeline is translated into a workflow. And the workflow is a complex feature. It's written in the YAML file. You can also use a visual editor just like on the right-hand side. In a workflow definition, we have triggers. And triggers are the one that initiate the workflow by the event such as git commit or when somebody create a pull request, then the workflow starts. Then we have actions, and actions are the main building blocks of our workflow. And here we define how we want to build, how we want to create our artifact, and where we want to deploy our artifact to. Next, we have environment, and environment is the one that we just created in our previous demo. Then the configurations, and configurations are the series of scripts and commands that we define how we want to run these build steps. All right, now we have the CI/CD ready. I want to spend a bit of time on the step 3 during our development stage. During development, we can do a number of local testing, as you already know, unit testing, code quality testing, and I want to show you a demo how you can do a secrets detection and static analysis security testing using the Amazon Code Whisperer. Just a quick refresher, Amazon Code Whisperer is the AI power tool, and I'm going to use a few features on the Code Whisperer, such as it has a built-in code generation, built-in security scanner, and also built-in reference tracker that if when the Code Whisperer generate a code, and if that generated code resemble something similar to our training data, it can flag that information. You can decide whether to incorporate into the code base. So that's what we're going to do in this next demo. And step 4 is our build stage. And during step 4, I want to introduce 2 new approaches. First, software composition analysis, SCA. SCA is used to identify vulnerabilities in our third-party packages and in our libraries. So we're going to use SCA scanning. Next, we will do SBOM, software bills of material. We will create an SBOM to get a full inventory of our libraries, our package, dependency, perhaps transitive dependency in our package to get all that information. So we'll generate SBOM in the second demo. All right. Let's take a look at the demo. Imagine you are a developer. You use a visual editor as your IDE. And here I have a sample application. So I have a sample application written in Go language. What we're going to do is we're going to run a security scanner on the application and see what's come back with. Before I do that, I want to show you what's inside that Go application. So let's go and check out main.go file. Inside the function, we have HTTP, which is to accept requests, response. We have GitHub basic authentication function. We also have a render template, which is taking the user input, passing it into the file. Pretty standard stuff, right? But what if there are security vulnerability lurking in our code? Let's run a security scanner and see what's come back with. So it comes back with 3 potential issues. First, insecure connection. It's complaining about the plain HTTP listener. Second, hard-coded credential. It's pretty obvious stuff, but it also gives you the information about why it has been flagged. Last but not least, cross-site scripting, which is the OWASP top 10 vulnerabilities. And it also gives the information about improvement and best practices for me to quickly go in and fix this issue. I was a developer in my past life, and I made a lot of mistakes. I made a lot of mistakes in production. And as a developer, being able to get that real-time feedback within the IDE can improve my code quality, start writing code with security in mind, and overall generally to improve the productivity really easily. Moving on to the build stage. Now we want to integrate our software composition analysis into our CI/CD pipeline. So here's how we're going to do that. First, we want to tell Code Catalyst that to recognize any generated report from this scanning result, so we enable the auto-discovery reports. Next, we define the success criteria. So here we're telling Code Catalyst that if there's more than 1 median severity in our scanning result, we're going to stop the pipeline. We won't run it anymore. Next is the configuration. Here I'm using the OWASP dependency checker to scan our directory for any dependency vulnerability issue. You can use other tools as well. All right. The previous YAML file is converted into a visual editor, and I want to show you how it looks like. So if you read the workflow from the top to the bottom, the first 3 steps are the infrastructure as code. The 4th step is where we're interested. You can see 2 parallel tasks, generate SBOM and OWASP dependency checker with the green tick. That's where we're interested in, which means that the task has been run successfully. However, the last step, EKS app build, that hasn't run yet. And you can see the error saying because it's more than 1 median severity that we defined in the previous YAML file. So let's dive a little deeper into it. Let's take a look at the generator report. In the report tab, you can see OWASP dependency checkers generated. We found 13 vulnerabilities. Report status is failed because there are more than 12 median or more severity. And on the right-hand side, you can also see where the severity score. For each of the findings, you can also see the severity, the score, and also the package that's impacted by it. And if we click on the CVE, there's also a detailed information about what the issue is, the link to the external libraries and the references. So I can use this information to whether upgrade the package, downgrade the package, use that information to reduce the vulnerability in my software supply chain. Next, we're going to generate the software bills of material as part of our CI/CD pipeline. And here what we're doing is we're using the Cyclone DX framework to generate SBOM, and we're creating sbom.json file. What I wanted to show you is what's in the sbom.json file created. So we're back in the VS Code. Let's take a look at the sbom.json and what we can do with that information. In the sbom.json file, you can see we have metadata information like the framework, the timestamp. We have hashes for the integrity verification. We have components, our first-party component, our third-party components, with all the information about the license, the release note, and then the relationship between them. So combining this SBOM data and SCA can really form a strong strategy because you have full transparency of all your components, what's going on. You can use that information to reduce the vulnerability in your software supply chain. All right, just to quickly recap, we talked through a Secure-SDLC stages. I'll show you 2 demos on how you can integrate during your build stage and development stage. And there is more details on the right-hand side, the QR code for the full deployment pipeline. Now, I'm going to hand over to Ahmed for the second part of the presentation. Thank you.
Thank you, May. So for the remainder of this session, we're going to talk about how you can use digital artifact signing and attestations to improve your software assurance. It's been one of those topics that's been sort of very important for our customers lately, especially more so in the last few years because of everything that's been happening. So before we go into like how do we do artifact signing on AWS and how to sort of implement that in the demo, it's important to understand, do a quick recap of what are the benefits of artifact signing, right? So the first thing is artifact signing provides us integrity verification. So making sure that the artifact is not being tampered with intentionally or unintentionally. And that's an important property or security control that you want for your artifacts. Secondly, it's the source authentication, right? You want to make sure that the artifact is coming from a trusted source. Think of an attack where there's been malicious code injection or there's been a typo squatting attack. You want to make sure that the artifact that you're consuming is actually from a trusted source and it's not been tampered with or malicious in intent. And that's why you'll see that a number of frameworks, security frameworks and best practices guidance now require that artifact signing should be sort of part of your day-to-day, how you build your software and how you publish your software. This is not an exhaustive list, but I have listed a couple of them, one of them being the SALSA framework. So if you look at the SALSA framework, it requires SALSA level 2 and level 3 requires that all artifacts should have authenticated, non-falsifiable provenance for each artifact that's produced. Similarly, AWS DevOps sagas, this is a newly released DevOps, well-architected guidance on DevOps that sort of mandates that artifact signing should happen at every single build, and you should also verify it. So, and this is just a couple of them. There are quite a few others that sort of mandate and require this artifact signing and verification. If you want to read more about SALSA framework, you can read about it on salsa.dev, which has got all the 4 different levels and the 3 different levels and all the details in there. So with that out of the way, how does artifact signing work on AWS, right? So AWS has got AWS Signer, which is a fully managed code signing service. So it takes care of all the code signing, key management, key rotation, revocation of the signatures, all of that provided as a fully managed service that you can use for your code signing purposes. So the first thing you'll do is you'll create an AWS Signer profile, which basically has your keys and all your profile details. Then you'll use that AWS Signer profile to sign your artifacts. That could be OCI, which is your container images. It could be zip files for your Lambda code, for example, or it could be IoT binary files for your IoT services on AWS. And then once you've signed your artifact, you can deploy it to any of these deployment targets. It could be EKS, could be a Lambda, could be FreeRTOS or AWS IoT platform. Now, one of the important things and sort of the key features of AWS Signer actually is that when you try to deploy these artifacts to these targets, they actually verify back with AWS Signer to make sure that it's actually being signed by the given profile. B, that the signatures are still valid, and C, that there's not been any revocation of the signature. So a lot of that stuff that's very sort of heavy lifting that customers normally have to do, AWS Signer along with these services provide that out of the box. Now, it's one thing to have your signing artifact signed, right? So it gives you that assurance. We talked about integrity, we talked about authentication and all that stuff. But it gives you a very sort of binary options and choices. Either you trust an artifact that's signed or you don't trust it. And if you trust it, you don't have much context around what about any other aspects of the artifact. Was it, for example, is it vulnerability free? If you just go with signing, you can't really ascertain that the artifact that you're consuming had no vulnerabilities. You might want to check when was it last scanned, because you don't want to be consuming something that was, for example, scanned maybe a year ago or 6 months ago, right? Things might have changed. Similarly, for a signed artifact, when you trust it, just because it's signed, you really don't know what the composition of your software is. It could be using a lot of open source components, what the licenses type for those components are they compliant with your organizational standards? And similarly, what are the vulnerabilities on those dependencies that you've got? So just because they are signed does not tell you or answer these questions for you. Lastly, and something that's been very relevant is the whole provenance of the build environment. So how was the software built? What was the build environment? What was the code base that was used, the agents, the parameters? Just a sign artifact would not answer you or provide you any context around these data around the build environment that was used. So options are pretty limited. While artifact signing does provide you great sort of authentication verification, but your options are very limited in terms of trusting it. It's either a binary yes or no kind of answer. So that's where attestations come in. With attestations, we're able to provide a lot more context to artifacts and be able to use that context and that data at runtime to make decisions, more granular, risk-based, fine-grained decisions on how we deploy these artifacts, and if you want to make a decision not just because the artifact is signed, but all these other aspects of it as well. So as an example, we have an artifact which we have signed, but now with attestations, we can add all these additional context to it as well. So things, for example, like the software bill of material. So you can generate the software bill of material and attach it with the signed artifact. That way, when consumers use it, they can validate it. Similarly, vulnerability attestation. So you can run a vulnerability scan, and then the result of that could be attached to the artifact. So it lives with the artifact, and that way it can be verified. Build provenance attestation, we spoke about the build environment and how that sort of is important and critical, how the software was built and the build environment and the build agent and the code that was used. Lastly, the custom attestations, right? It's one thing to have all these other attestations, but custom attestations are really powerful. You could literally use any of your custom in-house tools. Could be your change management tool, could be a quality assurance tool. It could be even a human manual approval that you say somebody's actually reviewed this and approved that. You can convert that to an attestation and put it, attach it to your artifact. And the consumers, during runtime, during deploy time, can actually have policies to check for those additional context and data that you've got now. So attestations provide you this power where you can go very fine-grained in how you define your policies before you consume an artifact, not just because it's signed or unsigned. So with that said, we've got a demo, and we're going to sort of demonstrate like how the options, we will set up a policy that sort of checks for these things, and then how sort of the policy implements and validates whether a container is signed and all the attestations that we go with. So for the first part of this demo, we're just going to walk you through how we build our container images. So very simple, we use Amazon Code Catalyst, we could be using GitHub, GitLab, doesn't really matter in this context. So we build our container images, Docker images, we push that to Amazon ECR registry that we have set up. And next is where the interesting bit comes in. So we use, as I mentioned, AWS Signer, along with the Notation CLI, which is a CNCF project for Notary version 2. And then we use the Aura CLI to sort of build, sign, and attach those attestations. So the Notation CLI basically helps us to sign artifacts and then verify those signatures as well. The Aura CLI, so Aura is the OCI registry as a storage CLI. It's a sandbox CNCF project at the moment. And what it does, it allows you to attach arbitrary data and store it in your ECR container registry, any OCI compliant registry. In this case, it will be our ECR registry. So think of it now that this enables you to store things like attestations along with your container images in your ECR registries. Once we've done that, we push the images back to Amazon ECR registry. And now we've got our ECR registry, the containers, and all the attestations and the signatures for them stored within that registry. For the second part of this demo, we're going to try to deploy those container images to an EKS cluster. So the flow will be left to right, sort of the API server receives the request for deployment for a pod. We've already installed a Kyverno admission controller. Kyverno is a Kubernetes native policy engine. And we've set up some policies. I'll walk through the policies in a bit as well. And we've also set the Nirmata extension. And what the Nirmata extension does, it's got the AWS Signer plugin. And when the admission controller receives the request, it passes on to the Nirmata extension. That goes back to AWS Signer and AWS ECR to make sure the signatures are valid, attestations, and all that stuff. It gives the response back to the admission controller to verify that, here's what I got as a result back from AWS Signer and AWS ECR. The admission controller then makes a decision whether to admit the pod or to deny admission to the pod. So a quick overview of the cluster policy. This is the Coverno cluster policy. We've omitted a lot of the stuff. I just put in the key stuff that we've got. So we've got some rules here that we will validate our pods against. The first one is the image must be signed. So we've got this as a policy, cluster policy. We're limiting it to a certain ECR registry, and we're saying it has to be signed by the trust policy. That trust policy has got a reference back to our AWS signer profile that we've created. The second thing we've got is we want to validate the SBOM and the licenses that we've got in our artifact that we consume. So here, for example, if you look at the first rule, it says all the licenses must be GPL or Apache, otherwise it'll be rejected. And lastly, we want to standardize, for example, on the SBOM format. We want the Cyclone DX format for our SBOMs. If it's any other format like SPDX, for example, it will be rejected as well. Or if the attestation doesn't exist, it will be rejected as well. The fourth rule basically talks about vulnerability. So one of the things we'll do is we'll scan our container, attach the vulnerability report. During the deployment time, this policy will make sure that there are no high risk or critical risk in our container images. If there are any high risk or critical risk, it will deny them access and admission. So with that, I'll go to my demo. So let's make sure you see it. So we've got a couple of repositories and core catalysts that we've created. The first one is the container signing repository, and the second one is the DOP 407 repository. So the first one is the one where we build the container images, sign them, and push them to the ECR registry. And the second one is where we try to deploy them to our EKS cluster and see how those policies that we have set up, how they kick in. So quickly going through our container signing repository. So this is the workflow that we've set up for EKS, for Code Catalyst. And as you can see, there's some variables that we've defined, like signer profile, which signer profile is going to be used, ECR repository, and we've got some tags. So what we're going to do here is we are actually going to try to build 3 container images and push them to our ECR registry. One of them is unsigned, so it's not signed at all. One of them is signed, but it's got vulnerabilities in it. And last one is signed, and it's got no vulnerabilities in it. So we want to see how the policy sort of evaluates this at runtime and then makes a decision whether to allow the pod admission or not. In terms of the code, we've got 2 scripts. One is the download tools. Nothing fun is happening here. We're just downloading the tools and installing them. And then lastly, we've got the build and sign container image. So that's actually signs and builds our container images. So if I quickly go through the Docker files, we've got these 3 Docker files. As you can see, this is the sign one. They use the latest Alpine image for Python. No vulnerabilities, so this should ideally pass. Then we've got another Docker file that has got, it's signed, but it's got vulnerabilities. It's using an older version. And then lastly, we've got the unsigned one, which is basically talking about the unsigned container image that we've got. Now, if I go to build and sign Docker image script, so what we do first is we log into our ECR repository. Then these 3 steps, basically, they build the Docker image, push them, and then sign them using the notation CLI and using our AWS signer profile. Then we generate the gripe and the SIFT report. So the gripe is for vulnerabilities, SIFT is for SBOM. Then we use ORAS CLI that I mentioned earlier to attach this SBOM and this vulnerability report to our signed container image. And finally, we sign also the attestations themselves as well, because we want to make sure that those have the same tamper-proof credentials as well. Lastly, the discover command just prints out to make sure that everything has been attached successfully or not. The exact same process is repeated for the second one. The only difference is the last one, as you can see, not signed Docker image. This is the one we just build and push. We don't sign, we don't do anything here, and that's it. If you look at this is my ECR registry, the one we have set up for this demo. And if you look at it here, we've got the signed container image, we've got the signature, we've got the SBOM, all these other artifacts that you would not normally see in your ECR registry are now all stored in your ECR registry. So if I go now to the workflow that tries to deploy this, so we've got 3 manifest files, identical. The only thing that's changing is the image that they use. So this, for example, use the same signed image we created earlier. This one is the unsigned one. So this just uses the unsigned one. And we'll try to deploy this to our container image, to our EKS cluster, and then see how the admission controller for Kubernetes sort of makes these policies. So this is our workflow. We have set up 3 stages. The first one deploys the signed one. The second one deploys the signed with pod vulnerabilities manifest file, and the last one is the unsigned pod, right? So I've already run this, and I'll show you the output. So this is the pipeline. So since we have set up that policy that required containers to be signed, it has no critical and high-risk vulnerabilities. So this one, as you can see, is the deploy unsigned image. And if I go down here to the logs, and as you can see, this was failed because the container could not be verified, because we had set that policy, unsigned containers are not allowed, so it blocked that and prevented it. If I show the second one, so this was our container image that was signed, but it had vulnerabilities, high-risk vulnerabilities in it. And if I search for, in the logs for critical or high-risk vulnerabilities discovered, so that second policy that we said that even if it's signed, we want to make sure that there's no high or critical risk vulnerabilities. So now we're able to make that low-level, fine-grained decisions on the policy level as well. So that was denied access as well. And the last one, which was the container that had was signed and had no high risk or critical vulnerabilities. And if I look at the logs for this one, you will see that this one was actually admitted and it was created. So now we did not just trust the fact that the container or artifact was signed, we looked at a level below that, which was, do you have the right SBOM, do you have the right vulnerability scan results, et cetera, right? So with that, I'll move back to my slides. So some of the key takeaways, I guess, from this session is that security at every checkpoint, as left as you can move, starting from the developer workstation all the way to when you deploy and sort of run and do the continuous monitoring. It really helps you to scale up that way. Automation is the key. You've got hundreds of product teams, thousands of pipelines. The only way to scale this is through automation, and that sort of really helps you to set the standards and help your developers as well. Artifact signing, as I mentioned earlier, is becoming a very key topic for a lot of our customers. A lot of our customers started doing artifact signing in their organizations to make sure that it's sort of artifacts are signed. And lastly, try to experiment with attestations to move into that next level of fine-grained access, how you can make those policy decision, risk-based policy decision when you consume artifacts. So with that, I just want to talk about AWS Skill Builder. Skill Builder is an online learning platform service from AWS. It's got thousands of trainings on it. Almost 600 of them are free of access. You can go to skillbuilder.aws and sign up for a free 7 days trial as well. It'll give you access to unlimited courses so you can evaluate it as well. And with that, just want to thank you. Thank you for coming. Thank you for joining. And if you haven't downloaded the app, please download the app. And there's a link for the session where you can scan and give us some feedback on the session as well. Thank you very much.